In this video, I'm going to be working some accumulation function examples and working through BC Homework 7.2. And I think the big takeaway from this is that we can rewrite the fundamental theorem of calculus as f of b equals f of a plus the integral from a to b of f prime of x dx. That's the big new thing. And that we can then apply that to all sorts of different scenarios and kind of more efficiently compute values of an antiderivative using a known value and an integral of its derivative. Okay, so if y prime is 2 plus 1 over x squared and y of 1 equals 6, find y of 3. Well, y of 3 is going to equal y of 1 plus the integral from 1 to 3 of the derivative of y with respect to x. So I'm going to do this one without a calculator. I'm going to pretty much do all of the ones that don't say calculator without a calculator. If you got to do it with a calculator, that's fine, but just remember that you've got to be able to do this by hand in this course, so you should probably practice that too. So it's going to be 6 plus, I'm going to find an antiderivative here. That would be 2x. This is x to the negative 2, so I'm going to add 1 to the power, divide by the new power, and I'm going to let x run from 1 to 3. Then when I plug in 3, I'll get 6 minus 1/3. And then when I plug in 1, I'll get 2 minus 1. And that's going to be a safe place to stop. If f prime is cosine of 2x and f of 0 is 3, find f of pi over 4. F of pi over 4 will be equal to f of 0 plus the integral from 0 to pi over 4 of f prime is cosine 2x dx. So that's going to be 3 plus, okay, I anti-differentiate the outside, right? This is a linear inside, so I'm not going to need to do a u substitution here. But if you needed to, you could. I'm going to take the antiderivative of the outside while leaving the inside the same, and then dividing by the slope of the inside is that. Okay? And then I'm going to let x run from 0 to pi over 4. And here I'll have 3 plus half of sine of pi over 2 minus, when I plug in 0, I'll be taking sine of 0 and divided by 2. And that's 3 plus, okay, I'll go over here. Pi over 2 is up here, where the y-coordinate is 1, so sine is 1. So over here is where theta is 0, and sine of 0 is going to be the y-coordinate. There is going to be 0. So 1/2 minus 0 over 2 is going to be 0. And that's going to be 3.5. Okay. With a calculator, if f prime is cosine of x cubed and f of 1 equals 2, then f of 0 equals f of 1 plus the integral from 1 to 0, right? F of a plus the integral from a to b. Right, even if that's backwards, of cosine of x cubed dx. Okay. So f of 1 equals 2. Well, that didn't help much because I'm going to need to use a calculator for this anyway, because there is no closed form antiderivative for cosine of x to the 3 with respect to x. So I'm just going to need to go find a calculator, which might be more difficult. Okay, that's not good. All right, make sure I'm in radian mode. Okay, 2 plus integral from 1 to 0 of cosine of x cubed in the right mode. And press enter and get 1.068. Okay. If f of x equals e to the negative x squared, that's another one that doesn't have a closed form antiderivative, so we've got to use a calculator. F of 2 equals 1, f of 5 equals f of 2 plus the integral from 2 to 5 of f prime. Okay, so that's going to be f of 2 is 1. Let's see, right over here. F of 2 is 1 plus the integral from 2 up to 5 of f prime is e to the negative x squared, e to the negative x squared. right? And that's got to be the negative button, like there, not that minus. Okay, they're different. I know you know that, just reminding you. With respect to x, and that's going to be 1.004. Yeah, e to the negative x squared, by the time x gets bigger than like 2 or something, it's just like really, really small. So it would not be surprising that it would not contribute much area. And so that, wait, what was that? 1.004. All right, let f prime of x be this, and it goes through 3, 6. Find the value of f of 3.1. Well, f of 3.1 equals f of 3, which I know is 6, plus the integral from 3 to 3.1 of f prime of x dx. So I'm going to just say that that's equal to f of 3 is 6, plus the integral from 3 to 3.1 of the, where it is. I'm going to just put in a fraction bar there using f1, and I'll call that, okay, 1 plus e to the x divided by x squared dx. And I get 6.238. If f is the antiderivative of x squared over 1 plus x to the 5, with f of 1 equals 5, then f of 4 would be what? Okay, well, f of 4 equals f of 1 plus the integral from 1 to 4 of x squared over 1 plus x to the 5 dx. Right, because you could say, well, if f is the antiderivative of this thing and I integrated it from 1 to 4, I would get the net change in f between 4 and 1. So, you know, 1 and 4, however you want to look at it. All right, so f of 1 is 5 plus the integral from 1 to 4 of, I'll put in a fraction bar, x squared over 1 plus x to the 5. All right, and 5.376. The graph of y equals f prime of x is showing it right. It is known that the integral of that, so pretty much, okay, get this in the shot, from 1 to 4, basically that amount of area is 6.2. That's what they're saying. So if f of 1 is 3, f of 1, I'm just going to go back to my rule, f of 4 equals f of 1 plus the integral from 1 to 4 of f prime of x dx, which just so happens to be already given to me. So it's going to be 3 plus 6.2, and that's arithmetic I can do. That's 9.2, right? Okay. The graph of f prime consists of 2 line segments and a semicircle as shown below. Given that f of negative 2 equals 5, find the values of f of 1, f of 4, and f of 8. All right. F of 1 is going to be f of negative 2 plus the integral from negative 2 to 1 of f prime. Okay, so that's going to be 5 plus, okay, if I go up to 1, that's just this triangle. And I'm moving forward, so it's going to be positive 1, 2, 3 by 1, 3. Okay, so it's half of a 3, but it's half of 3 times 3, which is going to be 9 halves. Okay. 9 halves is 4.5, so that's going to equal 9.5. F of 4 equals 5 plus the integral from negative 2 to 4 of f prime, which I know is going to be 5 plus 9 halves to get all the way up to this point. Then I'm going to have to add in the area of this triangle, but negative because it's below the x-axis. So that's I think that's a 1, 2, 3 wide by 2 tall. So it'd be half of 6 is 3. But it's going to be negative because it's below the x-axis. And then I think that's where I'm stopping at 4. Okay, so 2 plus 4.5 is 6.5. Or you could just say it was this minus that 3, right? And then f of 8 is going to equal 5 plus the integral from -2 to 8 of f prime, which I know is going to be all of this plus the area of that circle, or that semicircle. The area of the semicircle is going to be 1/2 of pi radius squared. Radius in this case is 2. So half of 4 pi is 2 pi. So it's going to be all of this, and then I'm just going to add on 2 pi more. And that was just because of the way that I just started from over here, and I just kept integrating farther and farther as I let x run 1 to 4 to 8 or whatever. All right, the graph of f prime is the semicircle shown below. Find f of -4, given that f of 4 equals 7. Well, okay. So f of -4 is going to be f of 4 plus the integral from 4 to -4 of f prime of x dx. Okay. But since I'm looking at, this is not something that I'm going to compute using a calculator, but it's a fundamental theorem or whatever, I'm just going to have to use geometry. I would prefer to integrate forwards so the area above the x-axis still counts positively. So what I'm going to do is I'm going to say this is 7 minus the integral from -4 to 4 of f prime. Usually I don't care if the bounds are backwards, I can just roll with that. But when you're actually doing the geometry, I would prefer to integrate forward, so I'm going to make that happen. So the integral from -4 to 4 of f prime is the amount of area inside the semicircle. Well, it's going to be 1/2 of pi times radius squared, so that would be 8 pi. So that will be 7 minus 8 pi. Grass clippings are put in a bin where they decompose. Classic AP calculus problem. For t between 0 and 30, the amount of grass clippings remaining in the bin is a of t. A is pounds, t is days. Find the average rate of change of a over 0 to 30. You can do this. Remember, you may have forgotten about average rate of change, but that's why I'm trying to remind you about it, is that it's all these things that you may be starting to forget about, they're going to start to come back. Because this is really the unit where we start to tie everything together for Calculus AB. And so the average rate of change of a on 0 to 30 is going to be a of 30 minus a of 0 divided by 30 minus 0. What I'm going to do is I'm going to let the calculator do that work, because this, I don't know how to put in 30. I mean, I could put in 30 and 0 for that and just write it as a really nasty equation, but I could also get a decimal approximation. So what I'm going to do, since I need to use this function twice, I'm going to plug it into y equals. So 6.687 times 0.931 to the t. All right, and so what I'm going to do, I'm going to set up a fraction. Wait, no, not math. I put a of t into y1. So I'm going to, whoops. Where do we get y1? Yeah, okay, alpha. y1 of 30 minus y1 of 0 divided by 30 minus 0 is going to be negative 0.197. The units of measure, this is like kind of an approximate value of the derivative, and we know that the derivative or the rate of change, its units are units of A divided by units of T, so pounds per day. Find the value of A prime of 15. Using correct units, interpret the meaning of A prime of 15 in the context of the problem. Well, all right, so if I'm taking the derivative, I'm going to use math 8. Take the derivative with respect to x of y1, where x is 15. I get negative 0.164. Okay. All right, so if A is the amount, this is the rate of change of the amount. And you kind of want to use that boilerplate that I gave you towards the beginning of the year. So at t equals 15 days, okay, remember that when they ask for units of measure, you have to give the units of the independent variable as well as the units of the thing that you're explaining. So we need to say at t equals 15 days, the rate of change of, hold on just a second, need a different color, okay, that's good. What is A measured? Amount of grass clippings remaining in the bin. Rate of change of amount of grass clippings. Oh, you couldn't see that I boxed off the amount of grass clippings in the bin in blue, but that's why I'm writing blue. I'm just copying the exact same thing that they wrote. The rate of change of amount of grass clippings remaining in the bin is negative 0.164 pounds per day. And that's my other unit. Okay, so we need both of them. That's kind of what I'm trying to tell you. All right, let's move on. F is defined on the closed interval -5 to 4. The graph of f is shown below. Let g be the function defined by g of x is the integral from -3 to x of f of t dt. Find g of 3, g prime of 3, and g double prime of 3. That's a lot for not very much room. Okay. The first thing I'm going to write down, if this was a free response problem, I might write it on every part, but I think for the most part, you're almost always going to just write it once. I know that g prime of x equals f of x, and therefore g double prime of x is going to be f prime of x, which is not something you can see, but now you can. All right, so g of 3, that's not something that I'm going to use one of those nice formulas for. G of 3 is the integral from -3 to 3 of f. All right, so from -3 to 3, that's going to be, okay, the area of this triangle plus a little bit more. Okay, so plus something that's going to be negative. Let's start with the area of this triangle. 1, 2, 3, 4, 5 is the base. 4 is the height. Plus, and then this is going to be a triangle. Let's see, what's the slope here? I think it's -2. Yeah, okay, so it's going to go down to -2 right there. So 1/2 times the base is 1 times the height is -2, and that's going to be my integral. Okay, and I could say that that's 10 minus 1 is 9, but I don't need to do that. Okay, g prime of 3 is f of 3, which is looking like 2. And g double prime of 3 equals f prime of 3 is also -2 because that's the slope right here. Okay, so like I wouldn't ask this question on a quiz or on a test or something because you don't want to be, I don't want people to be right for the wrong reason, and I can't tell. And so that's, I must have changed this problem a little bit because I doubt they would have asked that in the AP exam. Where's the graph of g both increasing and concave down? Okay, let's unpack that. G increasing means g prime is positive. G concave down means g double prime is negative. So, but I'm not looking at a picture of the graph of g, so I'm not going to be able to determine that. I'm looking at a picture of f, and g prime is f. So I'm going to say, where is f greater than 0 and f prime less than 0? So where is f positive and decreasing? And that would be right through here and there as well. So that would be from -5 to -3. And also from 2 to 3, wait, no. 0 to 2, positive and decreasing. This is where it went negative, so 0 to 2. All right, if h of x is g of x divided by 5x, find h prime of 3. That's good calculus. Okay, we're going to do that. We're going to say h prime of x first is bottom times the derivative of the top. G prime of x is f of x minus the top times the derivative of the bottom divided by the bottom squared. Oh man, I do know 15 times 15, that's 225. Okay, so this is just right at the edge of my arithmetic skills. But if we didn't know, we would leave 15 squared in the denominator, right? Not worth it, because it says no calculator. Don't be using a calculator. So h prime of 3 is equal to, okay, only if I needed to use f of 3 would I actually compute that. And so now I'm going to. That's 20 divided by 2 is 10, minus 1 is 9. So 5 times 3 is 15 times 9, minus, oh, hold on. Yeah, I did the wrong thing. And I don't have my eraser nearby. Okay, so here f of 3 is not 9. That's g of 3 that I did up here. That's going to be 9. That will go here, but I'm not there yet. So I'm going to, I've got my 15, and I'm going to be multiplying by f of 3, which we determined was negative 2 right there. Minus g of 3. G of 3 is what I computed to be 9 right here. Minus 9 times 5 divided by 15 squared. And although I do know that, I know all of these pieces, and you probably could simplify if you wanted to, I'm not going to. All right, if p of x is f of x squared minus x, find the equation of the line tangent to the graph of p at the point where x equals negative 1. All right. P prime of x, I'm going to take the derivative of the outside while leaving the inside the same, and then multiply by the derivative of the inside for the chain rule. Okay. To get I need a point and a slope here. So in order to get the point, I'm going to actually plug into p of x. Point is p of negative 1 equals f of negative 1 squared is 1 minus negative 1 is going to be f of 2. F of 2 looks like it's going to be 0. Okay, that's cool. Okay, I'll get my slope. I don't know how long I've been off my shot, but slope is p prime of negative 1 equals f prime of 2. Same computation there, times negative 2 minus another 1 is negative 3. Okay, so f prime of 2 back up to here, that's going to be the slope here, and that was negative, well, it's negative 2, it's the same line, so it's got the same slope. So it's negative 2 times negative 3 is equal to positive 6, and now I can write my equation. It's going to be y minus the y coordinate is equal to the slope times x minus the x coordinate. All right. Oh man, there's still a lot more. So g is defined on the interval negative 4 to 3. The graph of g consists of 2 quarter circles and a line segment. Oh yeah, I know this one. I like this one. F of negative 3 equals 2 times negative 3 plus the integral from 0 to negative 3 of g of t dt. And this is a backwards integral, so it's going to end up being the negative of what I would get normally if I did geometry. This is a quarter of pi r squared, where r is 3, so 9 pi over 4. But it's negative because I'm going from 0 to negative 3, so I'll have negative 6 minus 9 pi over 4. Okay, f prime of x is equal to, I got to take the derivative of this thing, that's 2. Plus, then I'm going to take the derivative of this thing, and that's going to be g of x. F prime of negative 3 is equal to 2 plus g of negative 3. G of negative 3 is looking like 0. Yeah, so that's 2 plus 0 is going to equal 2. Right. Find all values of x where the graph of f has a point of inflection. Okay, well, we're going to need f double prime. F double prime of x is the derivative of 2 is 0, plus the derivative of g is going to be just g prime. And f has a point of inflection where f double prime changes signs. So I'm looking for where g prime changes signs, so really where it changes from like increasing to decreasing or decreasing to increasing. And the only place to see that happening is right up here at x equals 0, right? Because over here is increasing this whole time, and then it becomes decreasing. Decreasing all the way to the edge. So I'm going to say that's only at x equals 0. Right, then I'm going to look at w of x. Oh, Ooh, this one's exciting. I'm glad I kept going. I got 10 more minutes to record because my kids are coming back from lunch, but this should be a good one. I think I can finish these. Okay, w prime of x equals f of, we'll throw in g of x, and then we'll multiply by g prime of x for the chain rule. So w prime of 3 is f of g of 3, okay, that's 4, so it's f of 4 times g prime of 3. F of 4 is going to be negative 1, g prime of 3 is 2, and that's going to be negative 2. If g inverse is the inverse function of g, write an equation for the line tangent to the graph of y equals g inverse at x equals 2. Oh man, it's been a while, right? May have forgotten about this. Okay, g inverse of 2 we find by setting g of x equals 2. We're going to find that. Here it is. That's where x is equal to 1. So I conclude that g inverse of 2 equals 1. Okay, that's going to be the point, is 2, 1. The slope is g inverse prime is 1 over g prime of g inverse, and I was going to change back to black there, but it's all right. G inverse we determined was 1, so it's 1 over g prime of 1, which is going to be g prime of 1 is 5, okay, right there, so it's 1/5. So then my equation is y minus g inverse of 2 is equal to the slope times x minus the x coordinate we want. All right, a table problem. For x between 0 and 4, so I'm going to start writing down my derivatives first. G prime equals f of x, and g double prime is f prime. Okay, for 0 to 4, find all critical points of g. Well, that's where g prime equals f is 0 or doesn't exist. Okay, so g prime, which is going to be f, is equal to 0. That's here and there, and that's 1 and 3. Okay, relative maximum, relative minimum, neither. Well, we're going to have to look at the derivative of g, which is f, to determine if it's changing signs. Here it is changing signs. So if f goes from negative to positive, that means g prime went from negative to positive, meaning g prime went from decreasing to increasing. G has a relative minimum. Okay, I would normally give more of a reason for my answer than this, but I'm kind of in a hurry and I've got more problems to do, so I'm going to say it's a minimum, but it's because g prime equals f goes from negative to positive. Here at x equals 3, I have another sign change where I went from positive to negative. That's going to be a maximum because if g prime, which is f, goes from positive to negative, that means that g went from increasing to decreasing, which is the hallmark of a maximum. Okay, find all values where g has a point of inflection. That's going to be g double prime equals f prime changes signs. That's going to be, okay, where does f prime change signs? Nope, didn't change signs there. Here it did, so that's x equals 2. We don't care that it D and E's at the place where it changed sign, right? Doesn't matter. And then that's the only time I saw a sign change, so that's going to be the only point of inflection. Just a couple more. Okay, if g of x is the integral from 2 to x of f of t dt, we know that g prime of x equals f of x. Okay, g of 0 is going to be the integral from 2 to 0 of f of t dt. And that's going to be the negative of this area that I'm going to find by taking the that rectangle and subtracting that half circle. So that rectangle would have area 2. And then I'm going to subtract half of pi times radius squared. Well, radius is 1. And so that's going to equal, well, pi over 2 minus 2, I guess. And g prime of 0 will be f of 0, which they're telling me is equal to 1. All right, now we're going to find all values of x where g attains a relative maximum. Well, that'll be where g prime, which I know is equal to f, goes from positive to negative. And, well, that'll be right here, right? Right there. And so that's going to be at x equals 3. Okay. Find the minimum value of g on -5 to 4. Okay. Well, we're going to need to... I'm going to come back to this one, and I'm going to do that one in just a second. I've only got 2 problems left, so I'm going to do this one first, and then I'll come back to the absolute minimum problem. Okay, so find all values of x where the graph of g has a point of inflection. Well, I know that's where g double prime, which, well, I didn't write it down, but I know that g double prime is going to equal f prime. Okay, so I'm going to say g double prime, which is f prime, changes signs at certain x values. We'll find them out. Okay, where is f prime changing signs? Where f is going from increasing to decreasing. So that would be here at 3. Here it's decreasing and it continues to decrease. So that's not going to be a point of inflection. Okay, so this is 1, x equals -3. I know you can't see, I just wrote it down on my list. Here is going to be a place where we were decreasing and now we're increasing. So that's going to be 1. And then over here at 2 is going to be another place where we went from increasing to decreasing. So -3, 1, and 2. All right, now we can do the absolute extrema question. Okay, find the absolute minimum value of g on the closed interval -5 to 4. Okay, remember with this one, we need to find all the places where g prime equals 0. And then we're also going to need to consider the endpoints. So x and g of x equals the integral from 2 to x of f of t dt. Okay, so -5 and 4. Did I do... Okay, well, I found g, already computed g of 0, and that's not going to help me at all. So I need g prime equals f equals 0. So that's going to be, I'll use a different color. Here at x equals -4, 1, and 3. Okay, I'm going to exclude 1 and 3. So x equals 1, no sign change in g prime equals f, so it's not an extrema. Okay, at x equals 3, g prime goes from positive to negative, meaning it's a relative maximum, meaning it's not a candidate for a relative minimum. Okay, so now I'm really only considering -5, 4, and -4. And I'm going to do those now. G of -5 is the integral from 2 to -5. Oh boy, that's kind of a lot. I'm going to need more paper. Okay, we already determined that the integral from 2 back to 0 was pi over 2 minus 2, so I'm just going to use that. But then I'm also going to have to subtract this amount of area and add that last bit of area just to find g of -5. So it's going to be kind of a lot. Equals pi over 2 minus 2 from going from here back to 0. Then I'm going to have to subtract the area of this trapezoid-looking thing, but it's not really a trapezoid, so I'm going to have to divide it up into maybe, let's say that's a 1.5 area, this is a 3 area, and this is going to be a 1 area. So you can't even see what I was just doing there. So I have 3, 4, 5.5, so I'm going to have to subtract 5.5. And then I'm going to add back, this one would be width of 1, height of -2, so that would be a -1, but I'm going to have to subtract -1, so I'm going to be adding 1. All right, so -7.5, -6.5 plus pi over 2. Okay, well, we'll put that in. Okay. Normally I would be annoyed because class is supposed to start now. I've got 7 people in here, but I need to finish this absolute extremum problem, so I think I can afford a little bit of tardiness. All right, at x equals 4, the integral from 2 to 4, oh, that'll be nice. That's going to end up being 0 because these areas will balance out. The area of this triangle and that triangle will be the same, and they'll be the negatives of each other because of, being across the x-axis from one another. So I will conclude that that's 0. And then the last thing I need to do is find g of negative 4, which is going to be like g of negative 5. I'm just not going to add that 1 at the end from going all the way back over that way. So what I'm going to do instead is I'm going to say g of negative 4 equals pi over 2 minus 5.5, not plus 1, because I'm not going to go all the way and use that triangle. And that's going to be negative 7.5 plus pi over 2, which is certainly negative because pi over 2 is less than 7.5, less than 3. So, all right, so I've got negative 7.5 plus pi over 2, and that's going to be the minimum value of g. Okay. And that was probably not, as detailed as I would be if this was the free response section of my AP exam personally, but it's going to be enough for us. And, I've got people spilling into my room right now, and I've got to deliver them the lesson on the next thing. So thanks for watching.